Hey everybody, welcome back to what we're formally working with, linear equations. So if you watch my 3 other videos on linear equations, you should have learned how to solve one-step equations, two-step equations, and multi-step equations. Then you should have worked a little bit with equations with variables on both sides and determining the number of solutions to those equations. So today we are actually going to be talking about absolute value equations. Now you might be saying, what? Aren't we still talking about linear equations? Well, I will tell you right now that absolute value graphs actually have 2 lines in the graph. But more on that later. For now, we're just going to stick to equations. So I want to remind you guys that an absolute value is simply a distance from 0. And I will also tell you that 2 numbers have the same absolute value except for 0, which the absolute value is of course 0. But 2 numbers have the same absolute value. For example, -6 and 6 have the absolute value of 6 because they're both 2 numbers that are 6 units away from 0 if you place them on the number line. So when you're solving absolute value equations, that is the big thing that I want you to remember as you're learning this. Okay? Alright, so let's get started. So we are going to have, so let's see if we can find the, okay, there we go. We have absolute value symbol right here. Symbol right here. Alright, so let's say I give you an equation like x plus 4 equals 7. How do I solve this? Well, remember I told you that 2 numbers can have the same absolute value, which also means that it is possible to have 2 solutions to this equation here. So how can we find those 2 solutions? Well, we actually have to break them up into 2 separate chunks. We take away the absolute value for this one, and then we do the same thing over here, except that the right side has to be negative. Alright? So, you know how to solve these, don't you? Hopefully you do. And if you don't, then you should know you have to subtract 4 on both sides for both equations. And for this side, you should have x equals 3. And for this side, you should have x equals -11. So there you have it, guys. 2 solutions. Do they work? Or do you just not trust me? Okay, well, I'll prove you that I am right by simply doing the check that I always do here. Alright, so we're gonna check x equals 3 first. So we're gonna substitute 3 in for x. You should end up with 3 plus 4 is 7, and then 7 equals 7. So that solution checks. Now, let's check the other solution. So we have x equals -11 is our other solution, so we substitute that in for x. It's plus 4, right? Okay, good. And does it equal 7? Hopefully it does. Now notice that this is still 7 units away from 0, guys. So this solution right here actually does check. So we have both x equals 3 and x equals negative 11 as valid solutions to this first equation that I just gave you. Alright, why don't you try one on your own, see how this works. Alright, how about I give you something like this? Alright, so we have absolute value of 3x minus 2 equals 6. So what I want you to do right now is to pause the video and try to do all this stuff on your own. If you don't want to do checks, that's fine by me right now, but I highly suggest checking them in case you might be struggling. Okay, so pause the video, solve this equation, check back with me in just a few moments. Alright, so if you solve this equation, I'm going to tell you if you got it right or not. Alright, so we have 3x minus 2 equals 6. We should take the absolute value away. We should have 3x minus 2 equals 6. Same thing here. And same thing here, except we have the right side negative. Now notice. Alright, so now we just solve from here. Hopefully you know that 6 plus 2 equals 8. Or 3 equals negative 4. And I'm really sorry, I did not plan this out well. Well, I guess I'm just that good at making fractional solutions easy to get. So we should have x equals 8 over 3. And then on this side, we should have negative 4 over 3. So there's your two solutions. I'm still going to check to make sure that we still did get it right. Get it right. If you're tired of me doing the solution checks, please stop the video. Please fast forward the video onto the next equation that I'm going to work out. So you're saying that's great. Great. Hopefully this will help you in the future. So I'm just going to, so it's 3 times 8, 24, divided by 3 equals 8, minus 2. Y, that does equal 6. Well, absolute value of 6, that is. And then 6, and then 6 equals 6. Solution checks. So now we know that x equals 8/3 is valid. Now, let's try x equals negative 4/3. Negative 4/3 equals negative 4/3. So I have to, sorry for the delay, guys. Alright, so we have 3 times negative 4/3 minus 2. Forgot to close the parentheses. Equals 6. And then 3 times negative 4 is negative 12. Divided by 3 is negative 4. Minus 2 is negative 6. And then 6 equals 6. So both solutions here are valid, and we're done. Alright. So now I want to show you them. Let's show you that might be hard to easy to miss. Yes, if you don't read closely. So Alright. Alright. Take a look at this equation right here. Equation right here. Equation right here. So, you might just think, oh yeah, I'm just going to solve this. Solve this. It's going to be 2x minus 4 equals 8 and 2x minus 4 equals negative 8. However, I want you to take note of the negative sign on the right side of the equation. I want to remind you that an absolute value can never be a negative number. Therefore, we can't really solve this. There's no, or you can, but there's really no point in doing so. So therefore, this equation is no solution. All right. Now, let's see if I can try to give you something a little more advanced. It's not the most advanced I'm going to give you, but it's kind of advanced. It will require you to work with stuff. Work with all kinds of stuff. Alright, so let's say you have something like this. How about this equation right here? And equation right here. Now you got all sorts of stuff going on. So imagine that the 2x minus 6 is your variable. It's kind of like using the distributive property. Now, let's say that you want to get that variable by itself. So, first thing you're going to want to do is I actually need to fix something here. This seems kind of awkward. How about this? Does that sound better? Okay, so we need to get the absolute value sign by itself. So what we're going to do is add 10 to each side. Then you should have this. And then you have a coefficient. So you got to divide each side by 3. And so you will get an answer. Absolute value of 2x minus 6 equals 20. Excellent. Now we're ready to split this up. We need to split this up. Alright, so let's give it a try. Okay, give it a try. So 2x minus 6 equals 20. Or 2x minus 6 equals negative 20. Let's solve each equation. On this side you should have 2x equals 26. And on this side you should have 2x equals negative 20 plus 6 is negative 14. Divide each side of each equation by 2, you should have x equals 13. Or x equals negative 7. Alright, this time we're not going to check, guys. Don't worry. If you want to try and check this for yourself, that's fine by me. Fine by me. You can try and find the errors that I made. But right now, I just want you worried about this equation that I'm about to give you. How about this? Yeah, I think that's good. So why don't you pause the video and try work this out by yourself. Then hit the play button and we'll get to solve it. Alright, go ahead. Alright guys, welcome back. And so we are ready to solve this now. So, unless you solved it already, of course. Alright, so we subtract 4x on both sides. Divide each side by 2. Alright, ready to split this up? Hopefully. Alright. So on this side you should have 4x plus 6 equals 6. And on this side you should have 4x plus 6 equals negative 6. Now solve each equation. On this side you should have 4x equals 0, because it's 6 minus 6. And then on this side you should have 4x equals negative 6 minus 6 is negative 12. Then you should have the following solutions. Alright, that's great. Neat. Alright. So now that we got that out of the way, want to try something harder? We talked about equations with variables on both sides, right? Well, how about you try solving an equation with two absolute values? The values. Values. So, how about 2x minus 6 equals 3x minus 2? Now, right now you might be going, oh no, two absolute value equations. Oh my god, we can't solve this. Oh yes, you still can. And don't sweat it. All you have to do is split this up into two equations. Just the way it is. So, basically we need to take the absolute value signs out for each equation. For each side of the equation for this side. Then, when we do the second one, we need to multiply everything in here by negative 1. So then you should have negative. Oops, I did not mean to do that. We should have negative 3x plus 2. Alright. Want to give it a shot? No, I gotta finish this first. Okay, so in this equation I'm going to subtract 2x on both sides, which I will have 6 equals x minus 2. And on this side of the equation should have, I'm going to add 3x to each side, and we're should have 5x plus 6 equals 2. And then add 2 to both sides, we have x equals 8. Subtract 6 on both sides, we should have 5x equals negative 4. Divide each side by 5. We're just going to drop the solution down. And then over here you should have x equals negative 4 over 5. Pretty cool, right? Now, try it on your own. Try one on your own. On your own. Okay. How about x minus 3 equals absolute value 3x plus 4. Alright, so pause the video, work this out, and then come back later when you feel like you're ready. Okay, let's try this out. So, for this first equation, we're going to have x equals 3 equals 3x plus 4. And the other side of the equation, we should have x minus 3 equals, multiply everything in here by by negative 1, so we should have negative 3x minus 4, and then we're going to solve the equations. So subtract x on 1x on both sides. This is what you should get. Here we add 3x to both sides. And then here we subtract 4 on both sides. Negative 7 equals 2x. And then add 3 to both sides here. Then we're going to get our final answers. X equals negative 7 over 2 here. Or x equals negative 1 over 4. Alright, so as you can see, absolute value equations can have two solutions. Now, is that always the case? Wrong. There are actually some times where there are extraneous solutions. And those are the apparent solutions that make the equation not true. So that's something you need to watch out for. That's why I always say check your work. Now, for this purpose, you do not need to check for extraneous solutions, but I take this note down. Check for extraneous solutions if there are variables on both sides. But an absolute value on one side. Now, here's where it's going to get important. Here's an example of where this is important. So let's say we have 3x minus 6 equals 4x. So what we do here is split this up into two equations. We should have 3x minus 6 equals 4x on here, and then on this side we'll have 3x minus 6 equals negative 4x. Alright, so now I'm going to, on this side, I'm going to subtract 3x on both sides. We're going to have this as our solution. And then here, I'm going to add 4x to both sides. Actually, subtract 3x next, because I don't want to end up with 0. Alright, so we should have negative 6 equals negative 7x. We're going to drop this down. Negative 6 divided by negative 7, x equals positive 6 over 7. Now, as you can see, variables on both sides, but an absolute value on one side. So, we need to check both solutions, because you should now know, because based on this information, you should know that there's only one solution. However, we got two. That's why it's important to check. So, let's check negative 6 first. Fix first. So check, substitute negative 6 on 6 for each time x occurs. We have negative 18 minus 6 equals negative 24. I say that works. Don't you? Alright, so negative 6, x equals negative 6 is an appropriate solution. Now, I bet you can guess that 6 7 is an extraneous solution. However, you should still do the check to prove that this is the case. Alright? So, what we're going to do is ooh, I totally messed up, guys. I am terribly sorry. I'm going to have to start this over now. So we actually have to do the absolute value side of the equation. Value side of the equation, not the full linear side. Alright. Hopefully this is better. Alright, so negative 18 minus 6 equals negative 24. Does this equal negative? Alright. Okay, so there's the sum right there. This is what you get. This is a statement that is not true. So I'm really glad I checked where I messed up on, because it seems as though the x equals negative 6 is an extraneous solution. Now, I still want to check 6 sevenths just to make sure that I'm doing the right thing. So we're going to do 3 times 6 over 7 minus, close parentheses, minus 6 equals 4 times 6 sevenths. Now, knowing the absolute value now has to be positive, and knowing this right here needs to be positive, 4 times 6 sevenths, it has to be positive as well. I think this is going to be a working solution. So, we still have to check just to make sure. So, 3 times 6 equals 18. We're going to divide that by 7. And then it should be 18 over 7 minus, I'm going to convert this into an improper fraction here, so it's 6 times 7 equals, I'm going to do a fraction again, 42 over 7, and then 24 over 7 will be this answer here. Okay, so 18 minus 42, because we have like fractions, I'll tell you that right now. I'm going to do 42 minus 18, so that'll be 22 plus 2 equals 24. We have negative 24 over 7. Ooh, I forgot I needed to add the absolute value to that, but don't worry, we're still on the right track. And see, there you have it, guys. 24 over 7 does indeed equal 24 over 7. Awesome. Okay, so now I'm going to show you another example where there might not be two solutions, but I want you to try to work this out on your own. It's going to be an equation with variables. It's going to be an equation with two absolute values. However, I'm going to write it in a way where the coefficients are the same. So I want you to pause the video, try to work this equation out on your own, and then see if you can figure out what's up with some same coefficients in this equation here. Okay, just pause the video, do the work, make the conclusion, come back when you're ready. Alright, so So if you have not figured out, I'm going to show you. I'm going to show you the case. So we're going to split this up into two equations. We have x minus 3 equals x plus 5. Or you can have x minus 3 equals, multiply everything here by -1. So we should have negative x minus 5. And then we're going to subtract x on both sides. Notice that we get this. If you remember the lesson from solving equations with variables on both sides, we have similar coefficients, but the constants are different. So therefore, there's no solution here. Now, just because there's no solution here doesn't mean there's no solution to the actual equation that we're talking about right here. So we still need to work out stuff out here. So we're going to add x to both sides, and we should get 2x minus 3 equals negative 5. 2x, negative 5 plus 3 equals negative 2. X should equal negative 1. And that is the only solution to equation. So yes, absolute value equations can have no solution, one solution, two solutions, or infinitely many solutions. So keep that in mind when you end up with situations like this, because the coefficient and constant rules for linear equations still exist for absolute value equations when there are two absolute values. And remember to always check your work when you have variables on both sides, but if there's only one absolute value. So if you feel like you need to take note of that, please rewind the video and copy everything I say. That's literally all I'm asking you to do. Alright, so that was a pretty long video. Got a lot to talk about. Hopefully this video gave you some insight on absolute value equations pretty well. And next time we're going to be wrapping up our section on linear equations. Then we're going to move on to linear inequalities. So I hope you guys enjoy this video, and thank you so much for watching today. Have a good rest of your day. Bye.